You've done this before, so it probably will look familiar to you, but let's review it. 2.4, number 1, says, remember, we still have to go back and get some of 2.3, so don't worry, we'll get it. Right now we're on 2.4, number 1, that says long division. Now, long division is that thing you learned like in 3rd grade or something. I don't even remember what grade we learned long division in. But it's where you set up the division sign and you actually do the division. Now notice, when I copied my problem, what did I include? The missing term. And with synthetic division, that is an absolute 100% mandate. You have to do it in synthetic division. You don't have to do it in long division, but it makes it so much easier to keep your work organized. So I would suggest that anytime a power is missing, so we're starting with a cube. Anytime a power is missing, did I turn this on? Yeah. So, anytime a power is missing, make sure you fill it in with a 0. Okay? All right, so here we go. Just like regular division. If you were doing regular division, you would ask yourself, what do I have to put up here to take times 5 to get 28? Right? And that's exactly what we're going to do here. What am I going to put up here to take times x and get x cubed? X squared times x is x cubed. Would everybody agree with me? You gotta match them. This isn't going to work if you don't match them. So whatever you got out here, figure out what you're going to multiply it by to give you this first number right here. So x squared times x is x cubed. Now, you also got to take the x squared times the -1. So I'm going to put an x squared up here on top. I'm going to take that x squared times x and get x cubed, and then my x squared times -1 and get negative x squared. Okay? Now, if I were doing long division with numbers, I'd put a 5 up here and a 25 down here. And then what would I do? What operation happens now? Subtraction. So now we're going to do a subtraction. You're going to subtract both of those, which means that's going to be a minus and that's going to be a plus. Because when you subtract, you change the signs. Now, this will always happen, kids. That first thing should be gone. If it's not, you've messed up. So now I've got 5x squared. All right, what do you do in a regular problem? You subtract, okay, then what? What do you do next? Bring down the next number. So we're going to bring down the next number, which is the 0x. Just like regular long division. And then you start all over again. What are you going to put up here on top so that when you multiply it times x, you'll get 5x squared? 5x. Perfect. Because 5x times x is 5x squared. And 5x times -1 is negative 5x. Now we subtract, which means both things change, both signs change when you subtract. These are gone like they're supposed to be, and now I have 5x, and I'll bring down my -2 and start all over again. So what do I have to take times x to get 5x? 5. So 5x, or 5 times x, and 5 times -1. Now I'll subtract. And now I got a 3. What's that? That's the remainder, because I'm all out of divisions. I brought everything down. I'm all out of numbers. So that's just my remainder. And my remainder is 3 over x minus 1. Just like if you did this problem and got a remainder, that 1 represents 1/5, right? That's it. Now the question we're heading toward is, remember, because we're all about factors. We want factors in order to be able to graph. would you say that x minus 1 is a factor of that polynomial? No, because what happens when you divide by a factor? You get a remainder of 0, right? If you're getting a remainder, you're not a factor. That makes sense to everybody? Okay, so think about those hard problems with the stars next to them. Our job was to figure out what the factors were. So a clue to being a factor is you don't have a remainder when you divide. All right, let's practice one more long division. All right, so this time we've got x squared minus 2. We have x to the 4th, 2x cubed, 4x squared plus x minus 3. I don't think anything's missing. Now, there is something missing in the divisor. That is not a deal. That's not a huge deal. It's not an issue. So don't worry about that. You can, if you want, put a 0 in that. Just makes it bigger. All right, here we go. What do I have to put up here so that when I times it by x squared, I'll get x to the 4th? X squared. Now, you can put that x squared anywhere you want up there. I don't want to confuse you, but I am anal about keeping things lined up. Helps me keep track of what's going on. So if I'm going to put an x squared up there, I'm going to put it over my x squared here, but it really doesn't matter. So x squared times x squared gives me x to the 4th. And then negative 2 times x squared gives me negative 2x squared. And you do want to write it over here because you're going to subtract, and you have to have like terms in order to subtract. All right, so now I'll subtract. That's gone. But now look, you're going to have your 2x cubed now, and minus 2x squared, and I'm going to bring down my x. There wasn't anything here to subtract, so that just gave me 2x cubed minus 2x squared, and then my x coming down. All right, here we go again. What am I going to take times x squared to get 2x cubed? 2x. So plus 2x, here we go. That's going to be 2x cubed. And this is going to be minus 4x. Remember, you have to take 2x times both of those. Now I'll subtract. Here's my negative 2x squared plus 5x minus 3, bringing the 3 down. All right, so now what's going to go up here? What do I have to take times that? Minus 2. So that'll give me my negative 2x squared. It will also give me a plus 4. Now I'll subtract. That means change the signs. So I have 5x minus 07 left. And I'm out of numbers, right? I brought this down already, so I'm done. So this time my remainder is 5x minus 7 over x squared minus 2. Long division always works. So anytime you are doing a division problem in polynomial land, long division will always work. Unfortunately, it's a hassle. It takes up tons of space and a lot of time. So for most situations, we are able to use what we call synthetic division. Do you remember that from last year? Synthetic division? I think you remember it when I put it up here. Let's look at the next problem here. This is number 2A, and it's another division. Instead of writing out the whole big thing like this, though, I'm just going to write the coefficients. 2, 4, 0, -1, and 1. Now, let's make sure everybody understands where those numbers came from. Do you see those are my coefficients of my divisor? Excuse me, my dividend, the thing I'm dividing into. All right. So notice, this is, you got to have this here. If you leave that out, you're going to miss the problem. So pay attention to what's missing and fill in zeros. Now out here in our little box, now does that look familiar? In a little box, I'm going to put 2. Now I want you to start making the connection between the graphing that we did and the graphing we're going to be doing by finding these factors. Remember when we had our things factored like this, right? And we were plotting the x-intercepts on the graph. This one was plotted at 2, and this one is plotted at -3, right? The number in the box is the same as where you would put the dot. Jesus?
Wait, why did you put a 0 as like it's -x?
Okay, oh wait, it is -x. There shouldn't be a 0 in there. Thank you, Jesus. For some reason, I think I was looking maybe at the next one. I don't know. You are exactly right. There is no 0 in there. Thank you for saying something. That would have been disastrous. Did that confuse the rest of you? Raise your hand and say, Mrs. Ford, what drug are you on? There should not be a 0 in there. 3, 2, 1. You're exactly right, Jesus. Thank you. All right, so, okay, now back to this. The thing that goes in the box is going to be the same as where the dot would be if you were graphing it. So when you have x minus 2, you put that dot at 2, right? So that's what goes in the box. All right, now we draw a line across. And if you're online, well, you're not, yeah, you're online, paper sorter. Leave a line in there because we're going to be putting some numbers in there. And always bring this guy straight down. So whatever that first number is, doesn't matter what it is, 1, 7, -18, doesn't matter, bring it straight down. Now multiply 2 times 2 and put the answer here. Add 2 times 8. Put the answer here, add. 2 times 15, put the answer here, add. Now we're done. Add the numbers. Remember that procedure from last year? Now, what does that mean? Well, remember the original problem was this 2x cubed thing, right? Getting divided by x minus 2. This is your quotient. But when you divide a 2x cubed by an x, you're going to have 2x squared. You have to go down a power because you're dividing. And then you'll have an 8x and a 15. Okay, what's that? That's your remainder. That is your remainder. This last number is your remainder. So the powers of the original problem, you have to reduce by 1 when you write your quotient. So if somebody wanted to know if x minus 2 is a factor of that polynomial, the answer would be no, because the remainder is 31. And we need the remainder to be 0. All right, let's try B. B is going to have some zeros in it. Let me see if I can get this right this time. 1, 5, 0, 0, -8. Jesus, did I get that right?
Yeah.
You sure?
Yeah.
Out in the box, I put a -1 because that's where the dot would be if I were graphing x plus 1 as a factor. So this guy comes straight down. Here we go. All right, keep an eye on my arithmetic. Anybody match that? Okay, so what's our answer? Well, remember, the original polynomial was x to the 4th. So when you write your answer, it will be x cubed plus 4x squared minus 4x plus 4. And that last guy is your remainder. So the really critical question for us is going to be, is this a factor? And the answer is no, because the only way you're a factor is if that number right there works out to be 0. Annie?
On like a test or something, will you tell us if we're supposed to do synthetic division or long division?
Oh, yes, I'll tell you. And we're almost always going to be doing long or synthetic, almost always. There are a couple of things, a couple of times when we have to do long division. If you are dividing by a factor like x plus 1, you can always do synthetic. It's when you start dividing by things like x squared minus 2x plus 5, then synthetic doesn't work so well, so we need long division then. Okay? But anytime, for most of our work, we're going to be checking to see if things are factors, and so we're going to just be doing synthetic division over and over and over again. Okay? All right. A minute, thank you. All right, I'm going to stop because we didn't quite get as far as I wanted, but I don't have time to do the next thing. So we'll stop there. Remember, 2.2 homework is due tomorrow.